Okay, so here we're going to continue on with what we had in the last, where I left off in the last class, in the last section right here. Here's this example. We're going to determine the phase for each of the following water states using the tables there and indicate the relative position in the PV, TV, and PT diagrams. All right, so let's see, do I have anything after this? After, okay, that's different. All right, so let's see if we can do this. Get our heads straight. All right, so we're going to determine these. We're going to start with this one, 120 degrees Celsius and 500 degrees kilopascal. Because this is a nice even, well, we could do either one. Let's take a look at both, if we can. Let's take a look at both. So we go to the PDF of this, and we're going to go back up to the probably table B.1.1. Right, B.1.1, and so we had 120 degrees Celsius right here. Boom. We see that's 198.5. All right, so here for this one, A, went from B.1.1 at T is equal to 120 degrees C, we have the saturated pressure at 198.5 kilopascals, and remember that's absolute. All right, so, but here we have a higher pressure, so therefore, when it's higher, press, so therefore we're in liquid state. All right, so if we were at exactly this temperature and pressure, it would be boiling. But because we have higher pressure, it will boil at a higher temperature, right there. So therefore, we are a liquid state, right? And we can also take a look at 500 degrees pascals. 500. That's a degrees pascal. Okay, so here was in B.1.1. We could go, okay, so we could, one thing we do, we could take a look at 500 or get close to, here's in between 500, and we can start interpolating. We're going to learn to interpolate very soon. We can interpolate and find what temperature that would be in between there, and you can see that it would take a higher temperature to start boiling than so we were at 120 over here, but if we were at that pressure somewhere in between these two numbers, we could predict that our boiling is somewhere between 150 and 155, and we could get kind of close by linearly interpolating in between there. But let's go down to the B.1.2 right here. Okay, so there's B.1.2, and we go to 500 right there. And so, like, sure enough, the temperature is 151.86. So B.1.1.2 at the pressure at 500 kilopascals absolute, the temperature, or saturation temperature, that's the correct word for it, saturation temperature is 151.86. So we're not high enough temperature to get it to boil. So that, once again, that reinforces that liquid. But let's take a look at B right here. Right now we have 120 degrees C. I wanted to write Fahrenheit for some reason. And we have a V of 0.5 cubic meters per kilogram. Right. So first off, we can kind of know, well, we don't know, right? Let's go to 1.1. So at B.1.1, let's see what the specific volume is going to be. And this is why I want people to bring their books. Just the first page, sure it is. Okay, so we were at 120, and let's see, that's going to be, we're going to have a fluid right here. Let's get, I'll highlight these. A fluid here. I'm going to highlight that one too. Okay, so it's going to be in between. Here is one that's completely vapor, 0.89186, and here's one that's completely fluid. And what we were told is 0.5. So it's in between the gas and the fluid, so we know that it's going to be a mixture. So I want to write down these things right here and write down the VF is equal to 0.001060 kilograms per cubic meter. And we don't need the gas. We just need the VF, the VFG, excuse me, 0.89080 kilograms per cubic meter. All right, so we want to try to figure out X. That's our goal here with this stuff I just wrote down. And so we know this is the main equation. F plus X VFG. We were given this right here at being 0.5, right? That was our 0.5. So we want to find out what percentage vapor it's going to be. So we get 0.001060 plus X and multiply that by 0.89080 X, and not a bad idea. Oh, you can't see that because of the light. And go. All right, so we're going to subtract out the 0.5, 0.001060 minus, divide 0.8908 divide, and I get 0.5601, and then that's fine right there. So what we have, what we could say is it's 56.01%. It's going to be vapor. Did I do that one right? Sure enough. And if you were to look up on these tables, all right, so these 2 points, right, we call them A and B, right? So I'll try to sketch them out here. Here's, okay, and they told us to do this on the PV. They told us to do it on the TV. I barely have enough room here. They told us to do the PT diagram. So we're already kind of familiar with what these look like. This one, remember, this is the one that looked kind of like that right there. Here's your triple point. All right, so nope, I'm sorry, my bad. I was reading them in order that they would be in here. That one was the one that I was just referring to, was the PT. So that would be kind of this guy right here. And so these were both the same temperature, right? So, and here's the triple point. So it's going to be somewhere up in here. And one of them was going to be in the liquid phase. It had a higher pressure. So it was like right in there. Is that right? Yeah, right in there on here. But the other was like right here, right? So this first one, this was A, right? It was a higher pressure than the saturation temperature. So this represents the saturation temperature. And this one right here, this was a saturated, well, not fully saturated sample, right? It stays on the line because we can't tell from this graph. It's got the same pressure and the same temperature all the way across, right? Which we could actually probably see better on these diagrams right here, where we had like maybe the PV diagram that has a dome. And these domes don't look identical to each other, but you know, we're going to sketch them out and they're going to kind of look pretty much the same. So right here, for a particular pressure, no, it's different pressure right here. For a well, this is a constant pressure right here, and so we're going to be like at 56 on the second one. We're going to be 0.56. So not just in the middle, but kind of over to the middle. We're going to say that's B right here. But if we're going to be at a higher pressure right here than that. So I don't, it's going to be somewhere in the liquid phase because it's going to be up here. So it's not quite sure whether we're going to go, it isn't necessarily directly above onto this thing. It's kind of hard to say. We don't know what the specific volume was. I guess we could probably look it up. No, yeah, it's difficult to say which one this is going to be right here. We might be able to look this up, and let's take it. We'll take a little detour here in a second and look at A. Let's see if we could find this. And I think they said 1.5. Let me double check on my in my notes where they had the that little graph that they said use this graph to find the tables, right? And they had a liquid one right here, 1.4. So let's take a look right in there. I'll also take a little detour, take a look at 1.5. There's 1.4 according to this, supposedly. But finishing up onto this thing right here, let's see. I guess we could just say here's the temperature, and here's, once again, it's going to be, we're not quite sure where this is, but it's the same temperature, right? It's the same temperature. No, we didn't know that. Okay, so one thing that we might want to look up, we didn't, I'm not showing it right here, I'm sorry. Oh, darn, I hope I showed those before. Yeah, that this was, when this is 198.5, right? That's one of the things we knew from this one here when we were in the point B. So 198.5, it's definitely going to be a, or did I do that wrong? No, that's the pressure. That's the pressure coming. Oh, sorry. Here coming along the TV. Okay, these are lines of constant pressure right here. So we have these things going on right there. I'm trying to think my way through this. Here's 198 kPa right in there. But this other one was 500 kPa, right? So there's the thing to consider. And then down over here, this would have been kind of how that leg goes right in here. So we're going to be on this line, maybe like right there, right? Because they had the same temperature. Yeah, right there. So here's going to be A, and here's going to be B. And I know I struggled a little bit with this, but that's just how you're going to have to do it too. And you're going to be asked questions along these lines. So I need practice with it too, obviously. But you need to, going to be asked probably on an exam to like draw something like these and to reason out where these points are that we're looking at. I'm going to go back to table 1.4 and check that out. 0.4. And see if we could find, this is for a compressed liquid, we are 120 degrees and 500 kPa. Can we find that? Here's 500 kPa. There you go. Right in there. You could find what the specific volume is going to be of this liquid of a 0.00106, right? So that's a kind of a means of comparison. I don't know if that does us a lot of good, but we could find it in here at least. All right, so that is the end of this video, and we will go on to the next one, which I think is an example.